45, 45, 90 triangles today. So remember that we are going to look at what's given in the diagram, and we're going to solve for the variables. So in this diagram, it's a 45, 45, 90 triangle. The hypotenuse is 10, and I want to solve for side length A and side length B. So I'm going to look at the information given in my 45, 45, 90. So according to my general diagram, the legs are identical, and that's one of the biggest hints I can give you, is use that information to your advantage. That the cosine of 45 degrees is 1 over radical 2, and the sine of 45 degrees is 1 over radical 2. So you know what's great about this? You only need to solve for one of the legs, and you've solved for both of them. Remember, this is the hypotenuse, and the two shorter side lengths of the right triangle are called the legs. So let's take a look at problem number 5. Originally, I was going to do 8 problems, but I was looking at the timer, and I was like, it's getting kind of long. So let's just say I'm going to solve for side length A. So I'm going to look, well, this time I don't really have much of a choice. All I have are 45-degree angles. So I'm going to look at 45 degrees. Okay, so I want to solve for A, and all I know is the side length of 10. So it doesn't really matter which one, but in this case, let's just say I do 45 degrees. A is the opposite side, and 10 is the hypotenuse. Okay, which trig ratio lets me use opposite and hypotenuse? The sine. So in other words, the sine of 45 degrees is equal to, in this diagram, opposite over hypotenuse, A over 10. So I'm going to look at my trig ratio. The sine of 45 degrees is 1 over radical 2. So therefore, 1 over radical 2 is equal to A over 10. And now I'm going to solve for A by cross multiplying. So now I've got let me erase that part right there. Radical 2 times A is equal to 1 times 10. Or radical 2A equals 10. So now if I divide both sides by the square root of 2, A is equal to 10 over the square root of 2. And that's okay with me. Now, let's just say I use the same approach, but I'm going to solve for B. So I look at the 45, 45, 90 triangle. Let's just say I focus on this one for now because that's the way my eyesight works. I like them in the bottom left like this. So I'm going to focus on B and the side length 10. According to my diagram, look at 45 degrees. I would have put that on top. B is the adjacent side, and 10 is still the hypotenuse. Let's just say I use this format. Which trig ratio can I use for 45 degrees? The cosine of 45 degrees is equal to B over 10. And now, what do you know? The same formula. The cosine of 45 degrees is also 1 over radical 2. So I go 1 over radical 2 is proportional to B over 10. And it's the same strategy. I'm going to cross multiply these, and I get square root of 2b is equal to 1 times 10. Now I'm going to divide both sides by the square root of 2 and get b is also equal to 10 over radical 2. And you can check your work with the Pythagorean theorem. I'm going to put the Pythagorean theorem on the side. So let's say this is my triangle. So 10 over. Sorry about that. 10 over radical 2. So if I square them, well, I'm going to square the numerators and square the denominators. 10 squared is 100. Radical 2 squared is just 2. Same thing over here. 10 squared is 100. Hey, that kind of makes sense. 100 divided by 2 is 50. 50 plus 50 is 100, so the Pythagorean theorem checks out. Okay, I know I took a lot of time on problem number 5, but we're going to save a lot of time by doing the same thing on problem number 6. Remember, big hint, the legs of a right triangle for a 45, 45, 90 are congruent. So see if you can solve 45, 45, 90 where the hypotenuse is 300 and you want to solve for A and B. Okay. All right. All right. Well, note to self, A is congruent to B because they are both legs of a 45, 45, 90. So if I solve for A, I've also solved for B. So let's say I'm going to solve for A. Once again, let's just say I use, you know what, I'm going to look at this one and say the cosine of 45 degrees is proportional to A over 300. It doesn't really matter because the cosine of 45 degrees, the sine of 45 degrees is still 1 over the square root of 2. And I'm going to cross multiply. So then I get radical 2 times A is equal to 1 times 300, or 300. I'm going to solve for A by dividing both sides by the square root of 2. A is equal to 300 over the square root of 2. Also, B is equal to 300 over the square root of 2. Okay? All right. Number 7 and 8 are a little bit different. What do you notice about number 7 that we haven't seen in problem number 5 and 6? Well, in the diagram, we've been given the hypotenuse, and we wanted to solve for both legs. Well, you know what? I'm going to take a look at 7 and 8 in two different ways. So check this out. I'm going to do 7 one way, and I'm going to do and then I'm going to do it another method. So method 1, let's just say I stick with trig. So let's just notice. First things first, it's a 45, 45, 90 triangle. So what do I notice about the legs? W has to equal 15 as well because the legs are congruent for a 45, 45, 90. So the legs are congruent in a 45, 45, 90 triangle, so that takes care of that. Now, let's just say I want to solve for x because I'm going to look at the 45 degree angle when I solve for x. Now, if I look at the 45-degree angle, I've got 15 and I've got x. 15 is the opposite side, let's just say, and x is the hypotenuse. So I'm going to use the sine ratio. The sine of 45 degrees, in this case, is proportional to 15 over x this time. And I look at my sine ratio, and that is 1 over the square root of 2 is proportional to 15 over x. This time I'm going to cross multiply, and this really makes me happy, because I get 1 times x, or 1x, becomes x. X is equal to 15 times the square root of 2. And just to make it clear, if you did it another way, I don't want to take this away from you. You could do this using the Pythagorean theorem as well. So let's say we know that W is equal to 15. Since one leg is 15, W has to equal 15 as well. So now our right triangle looks like this. 15, 15, x. Let me make that a little bit clearer. I'm going to use Pythagorean theorem. 15 squared plus 15 squared is equal to x squared. 15 times 15, that'd be 225. Well, 200 plus 200 is 400, so 225 plus 225 should be 450. And then it becomes a game of simplify the radical. So let me just break this down. Since the square root of 50 is equal to x, I'm going to break this down into, well, what can I break up in there? Let's go with 90 times 5 is equal to x. And I can break up 90 into, let's go with 10 times 9. Radical 5, radical 2, radical 3, radical 3, radical 5 is equal to x. I'm going to factor out the primes. Circle the twins. And I get 5 factored out and a 3 factored out. And finally, so you choose. Honestly, I love my trig ratios, but I want to make sure that you guys are not abandoned by you if you're by your love. I don't know, abandoned isn't the right word or not, but Pythagorean theorem lovers unite. You can use it if you'd like. Okay. All right. Last problem of the day. Once again, I'm given 9. I want to solve for A and I want to solve for C. What is your method to solve for this? Well, it's a 45, 45, 90. So what this tells me is that if one of the legs is given, then the other leg has to be 9. So A equals 9 because the legs are congruent in a 45, 45, 90. Now, I'm gonna look at the 45-degree angle. And I want to solve for C. I've got 9 and I've got C. 9 is the adjacent. C is the hypotenuse. So I'm going to use the cosine of 45 degrees. And in the diagram, the cosine of 45 degrees is 9 over C. So therefore, I'm going to use the ratio of 1 over radical 2 is equal to 9 over c. I'm going to cross multiply. And that gets me 1c equals 9 radical 2, or c equals 9 radical 2. Hope this was a much simpler explanation than just get a double dose of trigonometry. I'm going to mix up both cases in the next video. I'm going to put some 30, 60, 90s. I'm going to put some 45, 45, 90s. And you're going to be solving for the unknown sides. Enjoy.